In the last section, we looked at balancing chemical equations. In this section, we're going to use those chemical equations that are already balanced to look at some of the relationships, specifically volume relationships. This will really start you thinking about things in terms of conversion factors or converting from one quantity to another. And that is how this section is used in the textbook. So to begin with, if we look at this equation, we have hydrogen gas reacting with nitrogen gas to produce ammonia. And if you do this reaction, you end up with 3 volumes of hydrogen gas plus 1 volume of nitrogen to give you only 2 volumes of ammonia. And why is that? Well, down here what you see is Avogadro, who stated equal volumes of gas when measured at the same temperature and pressure contain the same number of molecules. And so the reason behind each of this is, if you'll notice, there are 7 molecules in every single flask, and so the ammonia molecule just contains more atoms. So when looking at these equations, the molar equivalent is 3 volumes, 1 volume, 2 volumes, and those are the coefficients in this balanced chemical equation. And so anytime you're working with gases, this is true, that if you take the molar coefficients, that's how many volumes would be converted in the reaction. And so we can have questions like this, where what volume of ammonia is produced when 2.5 liters of hydrogen reacts with excess nitrogen? So this is our problem. We're given a balanced chemical equation, or you're given an equation and told to balance it first. But in this case, it's balanced, it's ready to go. So we start out with 2.5 liters of hydrogen. You just place this here on the left-hand side. And then you include a conversion factor. Now, it's been a little while since we've done conversion factors, so the main thing is you want the hydrogens to be whatever you're converting from needs to go in the denominator. That way you can cancel out the hydrogens. And then whatever you're converting to is on top. So we're going from hydrogen was given in the problem, to ammonia. That's what you're trying to get. And then whatever those units are, that will become the unit of our answer. And then in order to get this 1.7, all we did was go 2.5 times 2 divided by 3 to give us 1.7. And we can do this with any number. As long as we're looking at something that is balanced and we're looking at volumes, then these coefficients can be used to solve the problem. So this is another example. So in this case, we have 6.8 liters of nitrogen, and that's reacting to produce ammonium. But in this case, if we look back at the last problem, notice, so this 2 and this 3 inside of this conversion factor go with the coefficients. So 2 liters of ammonia, 2 ammonias, 3 liters of hydrogen, 3 hydrogens. These are simply the coefficients in the balanced chemical equation. Likewise, it's the same thing when you're using nitrogen. Nitrogen is in the problem. This is what was given to us, 6.8 liters. That goes outside the parentheses, and then inside the parentheses is an equivalent. And this equivalent, everything in here equals 1. And so the idea is I can put 3 hydrogens over 1 nitrogen, or 3 hydrogens over 2 ammonia, and then back and forth. And you can flip it around however you want. But the main thing is 2 has to go with NH3, 1 has to go with N2, and that's just how it works. And so these will always be set up this way. But then your denominators need to cancel our numerator, and that number becomes the numerator in our answer, and then we just multiply across. 6.8 times 2 gives us 13.6 liters. Alright, let's do another one. In this case, we're starting out with 65 liters of hydrogen. I want you to try it on your own. You're trying to convert liters of hydrogen to volume of ammonia, so liters of ammonia. So try it on your own. Set up a conversion factor. What do you need to put on the bottom of the conversion factor? What do you need to put on the top of the conversion factor? And then do the math. So what you should have gotten was 2 liters of ammonia over 3 liters of hydrogen, because now your denominators cancel and you're left with ammonia on top, and 65.7 times 2 divided by 3 gives you 43.8. And you have to make sure you do it that way. Alright, now go read section 5.3.